Hello, in this video we're going to be looking at density, mass and volume. So the objective here is to calculate density, mass and volume using the correct formula. So the key idea, if we want to work out density, we divide the mass by the volume. So again, we need to be making sure that the units are consistent. So for example, if the density is in grams per cubic metre, the mass needs to be grams and the volume needs to be in cubic metres. So we can represent the density using a triangle. So we have density is mass over volume. So here's an example. A block has a mass of 200 grams and a volume of 50 cubic centimetres. Find the density. So the first thing, if we draw out the triangle, we have density is mass over volume. So if we're trying to find the density, we divide the mass by the volume. So the mass is 200 grams and the volume is 50 cubic centimetres. So 200 divided by 50, that is going to be 4. And the units for that is going to be grams per centimetres cubed. Here's another example. This time we have a liquid has a density of 1.2 grams per cubic centimetre and a volume of 30 cubic centimetres. We need to find the mass. So I'm going to draw out a triangle. So I have density is mass over volume. So if I want to work out mass, I'm going to times the density with the volume because mass is on the top. So the density is 1.2 and the volume is 30. So the mass is going to be 1.2 times 30 and that's going to be 36. And the units for that is going to be grams because the density is in grams per cubic centimetre and the volume is in cubic centimetre. So the mass needs to be in grams for the units to be consistent. Here's another example. So a metal object has a mass of 540 grams and a density of 2.7 grams per cubic centimetre. We need to find the volume. So if we draw out the triangle, we have density is mass over volume. So to work out the volume, we divide the mass by the density. So the mass is 540 grams and the density is 2.7. So to work out the volume, we're going to divide 540 by 2.7 and we're going to get 200, and the units for that are going to be cubic centimetres because the density is in grams per cubic centimetre, so the volume needs to be in cubic centimetres and the mass needs to be in grams, which we know it is. Here's another example. So object A has a volume of 100 cubic centimetres and object B has a volume of 300 cubic centimetres. So object A is 300 grams and object B is 450 grams. We need to work out which object is more dense. So to do this, I'm going to work out the density of both objects. So if we do the density of A, that's going to be the mass of A over the volume of A. So the mass of A is 300 and the volume is 100. So that's going to be 3 grams per cubic centimetres. And if we work out the density of B, we're going to do the mass of B divided by the volume of B. So the mass of B is 450 and the volume of B is 300. And 450 divided by 300 is going to give us 1.5. So that's 1.5 grams per cubic centimetres. So the more dense object is going to be object A. Here's an exam style question. So we have two liquids, A and B, are mixed together. A has a density of 0.8 grams per cubic centimetre and a volume of 150 cubic centimetres, and B has a density of 1.2 grams per cubic centimetres and a volume of 100 cubic centimetres. So the liquids are mixed and we need to calculate the density of the mixture. So this is the scenario where two liquids are mixed together and we need to work out the density of the mixed mixture. So to do these questions, what we do is draw out a table. So we have a table with liquid A, B and C. So A plus B makes C. So we need 3 rows for the density, the mass and the volume. So I'm going to put density and I'm going to put mass and I'm going to put volume. So we're told in the question that liquid A has a density of 0.8 grams per cubic centimetres. So I'm going to put 0.8 here. And B has a density of 1.2. So the thing is, a lot of people might think that we could work out the density of C simply by adding 0.8 and 1.2. But we cannot add densities to work out another density. It doesn't work like that because density is a ratio. So they're two fractions that we couldn't necessarily add unless we made the denominators the same. So the key thing is, if we're mixing two liquids, we can't add their densities to work out the final density. So what we need to do is work out the total mass, the total volume, and then divide those to work out the total density. So again, we're told in the question that the volume of A and the volume of B is 100 and 150. So I'm going to put the volume of A is 150, and I'm going to put the volume of B is 100. So to work out the mass of A, so if I draw out the triangle, we have density as mass over volume. To work out the mass of A, I'm going to do the density times the volume of A. So that's going to be 150 times 0.8, which is 120. And I'm going to do the same thing for B, so I'm going to do 1.2 times 100, so that's going to be 120. So what we can do, even though we can't add densities, we can add masses and we can add volumes. So we can say that the mass of C is going to be 240, because 120 plus 120 is 240, and the volume of C is 250. So now to work out the density of C, I'm just going to do the mass of C divided by the volume of C. So it's going to be 240 divided by 250, and that's going to be 0.96. So that tells us that the density of C is going to be 0.96, and the units are going to be grams per cubic centimetres. So here are some quick fire practice questions on this topic. Pause the video, have a go at these, and I'll reveal the answers in a moment. Okay, so well done if you managed to have a go at those. I've just displayed the answers on the screen, and that's everything for this video. So thank you so much for watching, and I'll see you again in another video. Bye!